Okay, now let's look at what happens in forward bias. Okay, forward bias. So forward bias means you apply a positive voltage to the P and negative voltage to the N, right? So here is the electron band energy band diagram for P, E, and N at zero bias. Okay, I will draw the forward bias on top of this. Zero bias. Okay, I want to bring it down slightly. Okay, now let's use another color. Let's use red color. Okay, now what happens is when you apply a positive voltage to the P and N, I mean you forward bias the diode, what happens is you actually reducing the barrier height. So the difference in, remember here VBI is the barrier height, right? So in forward bias you're reducing the barrier height, and again your formula will be discontinued. It means that here this barrier height will be less, something like that. Okay, and then you have that and it'll be there. So the red line here, the P is still the same. This is the P side, this is the N side. This is the N side. So you can see some tilting still, but the tilting is less. Okay, so this still AG. So you can see in forward bias you have reduced the barrier height, so the electrons in the N side can diffuse easily, because like a ball can easily climb the hill to the P side. Okay, and also the holes in the P side can easily diffuse to the N side. Diffuse. So when this happens, diffusion is due to the majority carrier. So when the diffusion occur, you have lots of current. So that's why in forward bias, the majority, what you want is in the majority current is due to diffusion. Not the majority, the net current, sorry. The net current is due to diffusion because of the majority carriers inside the PN junction. So that's how you can see in forward bias the current is very high because we have diffusion of majority carriers. However, in reverse bias, the purple line over here, the current is very little because no diffusion, right? No diffusion, but there are some drift due to the minority of carriers. So in zero bias, the Fermi level is continuous, hence there's no current at all. So that's how you explain the process of reverse, forward, and zero bias using energy band diagram. Okay, I think that's all for today.